Okay, welcome back everybody for today's final presentation. Dust mitigation and control systems are essential in grain handling and processing facilities to minimize the risks associated with combustible dust, protect worker health, and maintain operational efficiency. This session will focus on the revised National Fire Protection Association combustible dust standards and effective dust control measures to comply with new requirements. Our speaker is Craig Froehling, the manufacturing technology leader for Cargill. He is a graduate from North Dakota State University with a degree in agricultural engineering. In his 37-year career with Cargill, he has held roles as project engineer, plant engineer, maintenance manager, plant manager, and process technology lead in the wheat flour milling and rice milling business. Craig serves on the National Fire Protection Association Combustible Dust Correlating Committee and the Agricultural Dust Chapter of the Fundamentals standard that I'm also involved with too. So with that, Craig, I'll turn it over to you.
Okay, very good. Welcome to the 9th inning. The good news is this is the last session. I got to get away from that mic. This is the last session before happy hour. The bad news is it had to be me. So I'm going to try to keep this light and simple and stay away from that other microphone. Everybody knows what dust control is. We've got some examples here. I'll show you some pictures. Some things you've probably seen. I think we've got a few unique solutions that we've deployed globally that maybe you haven't seen. So I just wanted to share some of those things with you. And then just introduce you to what NFPA 660 is. And I think I lost a slide. Yeah, anyway. So for dust control, you got central dust control systems, you got point of use dust control systems, and then we're going to hit the NFPA 660 requirements, just pretending like you're going to put in a dust collection system. What parts of the standard should I be using? So the very basic purpose of dust control is to just keep visible dust emissions from leaving the equipment. That's all we're trying to do. If you go through your plant and you see a transition and there's dust blowing out, that's dust uncontrolled. So that's the kind of stuff you don't want to see. You're always going to have a little bit of dust sifting out that you'll have to clean up with housekeeping. That's why our housekeeping programs are there. Or if you have an upset condition like a choke or something, you'll clean those things up. So we want to focus on what normal operations is. So with central dust collection systems, everybody in here probably has at least one. Just a big, large dust collector with a network of ductwork connecting them. I only wanted to point out a couple of design details that I think are important to make these systems work. One is this capture velocity right here at the pickup point should be between 150 and 300 feet per minute. If you get too much higher than that, it'll start sucking product out of your equipment. And then the velocity for the ductwork to carry that product about 3,000 feet per minute. That keeps it from falling out in the ductwork and choking your ductwork off. Everything else is pretty simple. You know, dust collection systems are not that complicated. Your dust collector should have explosion venting, and then you should evaluate, do you need some isolation protection or not? And you don't always need it. You should do your DHA to help figure that out basis your application. Now I'm going to talk more about, I inserted this one. So here's some common solutions or common mistakes that you'll see. One, for instance, there are these pickup hoods that are too small. So if this is too small, your face velocity is too high, and you're going to be sucking product out of your piece of equipment. And it'll go back to your dust tank or wherever you're at. Or having your ductwork coming in without a transition. So all you got in this case is a really high velocity right at the outlet of the spout, and it's just sucking product out of the system. Another common mistake are modifications. So here's a picture of a ductwork system. This one was removed and blanked off. That's going to significantly change what's going on in the other half of that ductwork system. So the other one now is going to be a really high velocity. So now, your pickup points are going to be higher velocity, and you're going to start picking up product. and then potentially choking your system down. So try to avoid those things or look for those things in your facility. If you're walking around trying to figure out, why is my dust collection system not working properly? What I've seen most of the time is if your dust control system isn't working, it's usually an air imbalance. It's not, my whole system doesn't have enough air capacity. It's usually the air is going to the wrong places, in the wrong velocities. And if you've got grain or product in your dust tank, that's an indication that your pickup velocity is too high at your equipment and you're sucking product out of that equipment. So those are some things to be aware of. So those are all systems you've all had and known. Now I want to concentrate more on point of use dust control techniques, and we've got several to go through. So one of them is using a bin vent type dust collector that you just attach right to a piece of equipment. We've been doing this a lot the last 12 years, 15 years. Pretty much this is practically our standard now, because it creates negative pressure in the equipment, so the equipment doesn't dust out. And then the dust itself drops back down on top of the duct or top of the product. So it keeps the dust with the system or with the flow. And then you don't have any duct work for propagation. So it's also an engineering by design propagation prevention. Now whatever dust control or dust explosion protection you need, you got to put it on the equipment, not on the dust collector. But we do this quite often, particularly in the grain handling and even in our animal nutrition business. The bottom picture, you'll see an example of a loading spout. So in this case, the point of use dust collector is right here at the top. So product goes down the bottom, air and dust comes back up, releases the air, and the dust gets pulsed back into product. So this solution, conveyors, bulk weighers, even grinding systems, we use them for those, and then loading spouts. So very useful, and there's a number of vendors that have products that'll work for this. So another type of point of use dust control is actually controlling the flow of the product. So kind of the mantra is, if you can control the velocity of the product, you can control the air. If you can control the air, you can control the dust. So these you've probably seen also. This dust suppression hopper creates a laminar flow inside of it. Use them a lot on truck loading systems, so that the product or the air doesn't just blow out of a spout and blow everywhere. Now, we also think about other applications for these. So this is down in South America where we install them inside of a warehouse. So we've got a lot of big flat warehouses in South America. You're filling them, there's quite a bit of dust in the air when we're filling them. They might be compartmented, so part of it is being filled, part of it's being emptied with a front end loader. So the front end loader's in there and there's dust everywhere. So we started putting these in place, and this is a picture of our trial, and it works great. So, and the nice thing is there's no airflow, there's no wind, so you just get this beautiful laminar flow of product right down to the floor of the warehouse. So we've done this at a number of warehouses in Brazil, one in North America, one in Egypt, and I think we'll continue to deploy these solutions. Another way you can control the flow of product is through these flow control gates. So this is on a ship loader installation, but you can do it for barge loading or other types of loading, where there's level indicators in the spout, the gate starts closed, grain flows in, starts filling up the spout to the level sensors, then the gate opens. It just maintains this head of grain inside the spout. Again, you're stopping that airflow from blowing out the bottom of the spout, and that's where all the dust generally comes from. Now you'll take this and you'll put one of those point of use dust collectors right on the top of the spout or on top of the conveyor, and that'll suck the excess air out of the system. So that keeps everything negative, so you have a very, very low dust emission solution. And then another way is to really control the speed of the product through these. You've probably seen these presentations too around these DEM spouting designs. So they can model the flow of product through spouts and through conveyors. You'll get a colorful picture like this that indicates the speed of the grain through the spout. And then they can design a spout that'll take that grain and run it very laminar, nice slow flow all the way through your system to the next conveyor. The picture on the left is a picture of that. So they look kind of funny, you know, they're always turning, they're always a funny shape, but that keeps the grain running at exactly the same velocity all the way through the system, and it just lays it right onto the next conveyor. So again, you're controlling the flow, you're controlling the speed, you can control the air, and you can control the dust. So we've implemented all of these, and I can tell you they all work, if you do them right. So you gotta do them right. Okay, that was kind of dust control. And I'll have question and answers at the end. So raise your hand if you've heard of NFPA 660. Good, at least half of you have, that's good. Raise your hand if you've heard of NFPA 61. Hopefully everybody has heard about that. It's been around since like 1940. So what is NFPA 660? So I'm gonna just show you briefly, because there's lots of words in these NFPA standards, and I'll put you all to sleep. I'll probably put myself to sleep if I try to read it. So, but I'm gonna go through an example. It's not gonna cover everything you gotta think about. This is my disclaimer message on the front page. So NFPA 660 is essentially one combustible dust standard by combining all of the existing combustible dust standards that NFPA has. So you'll see 652, which was introduced in 2017. That's going to make up chapters 1 through 10. And then each individual standard that exists today will be its own chapter. So NFPA 61, which is what applies to us in our industry, that's chapter 11. The others are for wood, for metals, for powders, from plastics and chemicals, sulfur. Those make up the other standards. This one common standard will be introduced either December or January, so it's coming up this winter, coming up pretty quickly. And the committees have been working on this for almost 5 years now. Lots of debates, lots of discussions, lots of, you know, what's a fundamental, what's not a fundamental, and what's industry specific and what's allowed. So there's been many, many discussions over how do you do this and introduce it as easily and cleanly as possible to the general public who are going to be using it. So again, here's the chapter structure. You'll see chapter 11 is NFPA 61. But let's just say I'm going to upgrade my dust collection system. Here's this standard. What part do I need to look at to know what are the requirements for this dust collection system? Well, I highlighted these three. So we're going to assume that you know what your dust is and you know it's combustible. So I'm going to skip over the beginning of this part and just jump right into the others. So dust hazard assessments, you've probably heard of these. I'm not going to go through them today. You'd need another hour, 2 hours, 8 hours to explain how to do these things. But you need to be familiar with them, you need to know when you need to do them, and you need to know what those requirements are. So you can breathe a sigh of relief. We're not going to talk about those today. But we'll go into chapter 9. So chapter 9 is the hazard mitigation. Do not be intimidated with the numbers. So what I wanted to show you is how the numbers have been oriented to make this as simple as possible. So when you look at chapter 9, and I'm just going to buzz down to the bottom, you'll see here's a chapter, and here's 9.4, equipment design. You can run all the way down here to 9.433, which is requirements for dust collection systems. You know, start there. Start in chapter 9. You'll read through those. If you opened it, these are the beginnings of those requirements. I'm not going to read those, but I just want to show this is how it looks when you go into the standard. Now, like I said, we used to just use NFPA 61. So where's that information? Well, what I've laid out here is how does it compare? So this is chapter 9. This is chapter 9 that we just looked at. If you look over here, this is what's in chapter 11. So the committee's tried very hard to line up all the section headings and the section numbers to make it very easy to compare what's in the first 10 chapters and what's in the rest of the document. So when you look at a requirement in the first 10 chapters, you flip over to chapter 11, and if there's a number there with a heading, that means there's other requirements there. Those might be additional, those might be different, those might be in lieu of. That might say, don't do what chapter 9 says, do what this says. So it's very important that you're looking at both of those sections. And this happens to be what 11.9.4.3.3 says. So you just see there's some additional information in here, really that is legacy information from our chapter, from 61, that we felt was very important to keep. But you don't just stop at 9.4.3.3, there's additional sections here. There's sections on air material separators like cyclones and such, air moving devices and fans, duct systems, access doors. These are all components of a dust collection system. They each have their own section, and there's requirements involved in those. Most of them are very basic, like maintain air velocity so product doesn't fall out of the duct. Okay, yep, know that one. Build it out of non-combustible materials. Thanks, I knew that one too. So there's a lot of words, but there's not a lot of new. So, like I said, don't get overly intimidated by it. And then the other thing within chapter 9 to really understand, and this is, I think, where we're probably going to feel a lot of pressure for our industry, so we need to arm ourselves with knowledge and educate ourselves on them, and that's equipment protection. Explosion protection and explosion isolation. So chapter 9 is going to be very clear, if there's a hazard, you shall mitigate. Well, you got to go over to chapter 11 and say, well, in our industry, what do we say for our industry? And understand what those are. The better informed you can be, the better you can explain your position to the consultants that you might hire to help you do a DHA. Or explain your position to the fire marshal who's asking you, you wanted a permit to install this dust collection system, show me your DHA or explain your DHA to me, then your hazard analysis. So the better you understand this, the better you can explain the decisions that you've made. There, I tried to make that as painless as possible. So really, that's just a summary, very briefly, on dust collection systems and an introduction to NFPA 660. Now that you've heard about it, start educating yourself on it. And it'll take a little bit to get through it. Once it becomes available, buy a copy. Buy a copy, have it for your business, read through it. Have somebody in your organization who's going to read through it and explain it to everybody, so that you'll have it and you'll know what it is.
All right, Craig, I have a lot of questions for you, and I'm sure there's a lot of questions from the audience. Just curious, how many of y'all are members of NFPA? So, do you all know that you have to be a member of NFPA to get a copy of 660? Is that correct?
You can buy it.
You can buy it,
yeah.
But you get pay more if you're not a member. So if you join, that's one of the things too. So if you join, you can if you join the association, you can access it online.
Yep.
But you can't print it or download it. But if you are not a member, then you do have to make the purchase. And how long, I'm trying to remember, how many pages is this going to be?
Well, on this particular one, I would recommend you just purchase it in paper copy, because it's going to be something like 800 pages. So now much of it doesn't apply to ag, but when you have a document, you're trying to look at what's in the front of it, what's in the middle of it, and what's in the back of it. That's really hard to do paging through on an online document. So just plan to buy a paper. I'm going to buy a paper copy, so I have it. And you could get a PDF version if you want PDF, but I'm still kind of an old-fashioned paper guy.
So this is an industry consensus standard. So are you all familiar with industry consensus standards? This is very similar to NFPA, is similar to ISO, similar to ANSI, similar to those types of standards. And essentially the industry consensus standards is people like Craig, industry representatives, myself, other members that are in here, work with, there's representatives from industry, representatives from insurance companies, representatives from engineering companies, representatives from, there's consultants themselves that all work together.
SMEs.
Yeah.
From many industries.
Many industries that are involved in, and we've been involved in this process for quite some time. So I think, one of the first questions is what kind of changes to our industry are going to be happening with NFPA 660?
And maybe some of these you've already felt, but one of them is when you go to apply for permits for a project, at least that we've been finding, fire marshals know that this is existing now, and they'll ask for your DHA, or they'll ask to see it, or they'll ask us, send us your DHA. And we'll call them and say, you won't understand our DHA. You just can't send something like that out. But we can send you the results of it, right? So we'll send up a summary of it and we'll send that to them and they'll review that. But they just know, well, you're supposed to do a DHA. They don't understand it. They don't know your risk tolerance, but they just want to know that you followed the standard. So we haven't had pushback on them. They just want to know them and see them. So be prepared for those kind of questions. And then think about what you actually want to send to them. You don't want to give the barn away to them. So just give them the information that they really need. Other one, I think you'll start hearing it, and you've probably heard it already if you go to Jeeps or any other ones. There's a lot of good explosion protection companies out there, and they'll tell you what you need. They're salespeople, so they tell you what they want to sell. So you have to arm yourself with your information and educate yourself, so that when somebody says, well, Chapter 9.4 says you have to put isolation on all your dust collectors, you can say, yeah, but Chapter 11.9.4 says I can do a risk assessment and determine where I want to do that. So it helps understand where do I really have a risk and I need to do those kind of protections, and where do I want to avoid just buying Christmas ornaments for a Christmas tree. It all looks nice, but I didn't move the dial on risk mitigation because maybe I've already got everything that I need.
How should we prepare? I mean, how should industry prepare? I mean, what should they,
I am sure you'll start seeing blurbs about consultants doing, introduction webinars on how to do a DHA, webinars on what 660 is. I would go to multiples. Don't just do one, because everyone is one opinion. Even this is just my opinion. So get your information from multiple sources, read through the standard, and get that education so you become familiar with it and you get other perspectives.
I think this is the critical question. Is the DHA required by federal OSHA or any of the state OSHAs?
I don't know about every state, but OSHA, of course, can cite you for any hazard that they find at your site. I don't think they can cite you for not having a DHA because they don't have a requirement to do a DHA. But they'll ask you, do you have one? Because if you're going to follow 61, which is an industry voluntary standard, but if you voluntary to follow it, well, they're going to ask you, are you following all of it, or are you just cherry picking it? So I don't think they can cite you for it today. Legally, they can cite you for anything they want. It's just a matter of, do you have a leg to stand on to contest it if you wanted to contest it?
Yeah, and that's why, and I just want to make sure everyone understands, OSHA has not formally adopted or incorporated this by reference, right? So that's another thing to prepare for. If anyone says, well, this OSHA requires this, or this is something you absolutely have to do, that's with NFPA standards, it's the authority having jurisdiction, right? And the authority having jurisdiction, just as Craig was talking about, it's a fire department.
Usually it's the fire marshal, fire marshal's office. Or an insurance carrier. So your insurance carrier may require it.
Any insurance carriers in here? No. Okay. I don't. Do you have any? You may have some thoughts on this. Do you have any thoughts on this? I figured you might have all kinds of thoughts on this. Maybe we'll get you the microphone.
On this,
Josh, do you might want to?
yeah, I'm Josh Clymer with Nationwide Insurance. On this particular topic, Nationwide is kind of in a wait-and-see mode. We don't have the standard in front of us. We don't know what it says. We don't know, we haven't had a chance to evaluate it yet. The other side of it is we're all terribly aware that most of what we handle is a combustible, explosive dust. So in one regard, it really doesn't change things. It's kind of something we already know the hazard, the risk, the problem. But the other side of it, we don't really know what this standard is going to mean yet because we haven't seen it.
Yep. Yeah, there's the last version of NFPA 61 came out in 2020, and I thought that was a beautifully written document, a standalone document, very clear, telling everybody here's what you do. If you follow this, you're probably not going to have a dust explosion of consequence. You may have a pop, and your mitigation strategy works, but you won't have a consequence from it, or a serious consequence. 660 really isn't going to make you do something that you're not already doing if you're already doing what you're supposed to be doing. So think about it in those terms, other than potentially in your management systems. So pay very close attention to the management systems. So 660 is going to require an MOC. 61 requires a very simple MOC. So how complex or simple of an MOC process you're going to manage. There's requirements in there around training employees or training people on combustible dust hazards and SOPs. Pay very close attention to those, because I can tell you there's different requirements in Chapter 8 and Chapter 11.8. And arm yourself with that information so you make sure you're doing the right thing. Don't do nothing. Doing nothing's the wrong thing. Do something, but do the right thing.
And I think just to follow up what you were saying, Josh, too, I get questions all the time. I get calls from members across the country. I get calls from some of our state affiliates within GFA saying, do I need to implement the DHA? My insurance, the company that is providing coverage is saying we have to do this. And my response is, well, that's between you and your insurance carrier, right? If that's part of their policy, for the coverage that they provide, well, that's something you'll have to work out with them on, what is that requirement, right? Why are they implementing that? I think the main point here is that, from as far as federal OSHA, right, they have not incorporated this. We still have the grain handling standard, but right, I think we just want to make sure that everyone understands what that is.
But I'm sure OSHA will take a look at it and decide.
Exactly.
Should they adopt 660 as code or not? And I personally don't think it's written properly to be an OSHA code. I think it's written okay to be an industry standard, but you may start hearing that.
And because the reason you may be hearing about that is there is a current proposed rule, the Emergency Preparedness and Response Plan, right? And NGFA, we're part of a coalition, submitted comments that were due on Monday. But one of the main parts of that standard is OSHA had numerous NFPA standards that they incorporated by reference. They're proposing this. It's not a final rule. And obviously, the primary concern is that industry consensus standards do not do an economic analysis, right? Just like federal rules, you have to do an economic impact. What is the cost going to be? That's our central argument from the industry standpoint, is that while safety is very important, that is the focus of these standards. You don't, from the cost impact. So these are all factors. I know this is a lot of information. We want to focus on what the requirements are, the DHA, but want to make sure everyone understands, because just like Craig was saying, you're going to be hearing a lot of information coming out very soon, right? You're going to be hearing from the consultants, the engineering firms, a lot of information out there. And NGFA, we're planning to send out an alert to our members later this year once we understand what the final version is going to be.
Okay.
As far as dust control, didn't mention anything about applying oil to grain.
Yep.
And so how does that, it was part of the DHA and all these other requirements, how does that all fit in here?
Mainly because I forgot about it. So you can still use oil applications as a dust control means. We have some ports that we still do that at. It it's just very expensive. So our port facilities, they'll spend $3 to $4 to $5 million a year on soybean oil. So, spraying oil on grain. It works. You got to do it right and put it in the right place, but it's kind of expensive. But if you need an immediate solution, it's an immediate solution. It's a low-cost install, immediate solution, high cost to maintain. And sometimes we'll do that. We just need an immediate solution. We'll put it in, and then we'll work on improving our dust control systems over time, because that's a higher capital cost, and then until the point we can turn off our oil ad systems.
Anything else? Any other? You have a question? I'd throw this at you, but
It's
that's
coming,
not
it's
safe.
coming.
It's coming.
Here comes the mic.
Yeah.
So we've been debating this back and forth on the point of use collectors. When is explosion venting required? Because it says on bucket elevators it should be calculated into the vent of the bucket elevator, but then you go to put it on like a high roller or a belt conveyor or something. How do you explosion vent that?
Our DHA analysis of that is the bucket elevator has all the explosion venting. So don't use a POU on a bucket elevator that's not vented, right? That's a bad deal. So it should be vented. A belt conveyor, I don't perceive that as an explosion hazard. It's a fire hazard. That's why you have all the hazmat on it and such, but not an explosion hazard. So the point of use dust collector attached to it, a dust collector itself can't create an explosion. It can't be its own ignition source. It has to bring an ignition source up into it. So how do you prevent a belt conveyor from having an ignition source? Belt alignment, bearing sensors, speed monitor, all the same required solutions that we've been requiring since 1982. So that's how we use that. That's how we do that analysis, as we look at, is there a credible ignition source? And if so, how are we guarding that credible ignition source? The credible ignition source either on the equipment or upstream. So we control both of those, and then we can deploy those solutions. That's a good question.
I guess the question I have too is what's the difference then between the DHA and the NFPA standard between other DHAs? Is there anything specific or special about the one that's in the ag chapter?
Well, for agricultural dusts, you can use a checklist. So, there's a kind of a sample checklist in the annex material in the back. You can use that. You can create your own. For very simple, in Cargill, we created our own for very simple applications. So things like belt conveyors, bucket elevators, dust collectors, hammer mills, I'm missing one, grain dryers. So it's a whole bunch of questions. Behind there is some math around our risk tolerance and the risk matrix, the same risk matrix that we use for our high hazard processes. And that puts us at a place on this risk matrix basis our current protections. And if we look at it and say, well, we're one layer short, then we look to see, well, where do we need to add a layer of protection? And we do that on all of our equipment, but not all of our equipment is an explosion hazard. So we just document, this drag conveyor, this, whatever, this shaker is not considered an explosion hazard for these reasons, right? So we don't have a document on those. Now, if you have a more complex system, so those pieces of equipment kind of covers 70% of all of our applications in our industry. But you've got other stuff, like in our cocoa chocolate facilities, they're mixing cocoa powder and powdered sugar in a blender, as they're making, little chocolate candies. And so then you wonder, well, is that an explosion hazard? So I have powdered sugar, which is a very low MIE, very easy to ignite, and cocoa powder, and I'm going to stir that up in this enclosure. What do you do? Well, NFPA doesn't have a solution for that. They just say, if there's a hazard, you shall mitigate. So the mitigation method used there is nitrogen blanketing. So they put the product in the mixer, they fill it with nitrogen, and then they mix it. So they just displace the air, so now you can't have an explosion. Once the mixing's done, you suck the nitrogen back out, then you discharge your product. So those kind of solutions, you know, that's not a checklist solution. Those are more of a process hazard analysis that you would do in a high hazard process, and there's methods for doing that. So, but the majority of our applications are a fairly simple DHA will suffice.
Is the DHA and the NFPA standard going to stay the same, or could it potentially change?
So if you're familiar with 61, we said you only are required to do a DHA on belt conveyors or conveyors, dust collectors, spray dryers, there's something else, grinders. We had a specific list of things to do. You didn't have to do it on everything. In the fundamentals chapter, they said you have to do it on everything, every plant, every piece of equipment. So that's what's been in ours. And our committee has been on a lot of pressure to add more equipment to that. Now us in the industry have been pushing back on that pressure. With the reasoning basically is we've got 8,000 agricultural facilities in the United States, 8,000, with an incredible amount of legacy installations. We can't change all that. What we can do is look at our really high-risk equipment, which are dust collectors and bucket elevator legs and spray dryers for the most part. And today, moving forward, anything new we do, we're going to follow the standard just as it is. And generally, if you put in something new, you probably already are, because your contractors are starting to get up to speed. So focus on today and the future, and let's not focus too much on the past outside of the equipment that we know is a problem in our industry. Let's fix those problems. Leave the rest alone. They've just shown not to be that big of a problem. Doesn't mean it can't happen, but you know, with 8,000 plants and 100 million years of operating hours, we know what the problems are. So let's just focus on what our problems are.
There's one thing. Great presentation, by the way.
Yep.
There's one thing that it's in, since you mentioned that equipment list, but one thing that did get added in this proposed one, if you've already done DHAs. So if you haven't done, then I mean, you know, it doesn't particularly matter too much. But if you have, like we've done it similar to how you guys have with checklists and those established pieces of equipment, but they're proposing to add storage. So.
Yeah, and I haven't seen yet. The correlating committee is actually meeting right now to finalize that. And so it got proposed, got added, got voted in, and then, but in the votes they have to look at, well, who voted, you know, against that and why, and is that the right thing to do to make a modification? So it's possible the correlating committee will say, no, that was an existing requirement, let's not change it. So we won't know for sure what the final is until after this last committee meeting. But it's a good point. There's a possibility they'll come up and say, well, let's include storage bins, which to me isn't, you know, that's quite a different, you can't hardly change your existing storage bins. So it's, you know, it won't move the dial. Doing an analysis on a piece of equipment you can't change doesn't change the risk on the piece of equipment. So focus on what you can change, focus on where you can move the dial, and but we will have to keep an eye on that, see if anything does get added to that list.
And for the record, Jason, Craig, and myself, we all serve on the fundamentals, and we serve on the agricultural dust chapters within the, I guess now the fundamentals, yes. So,
you know, if you think about, well, what if it does? What if they say, well, you have to do a hazard assessment on grain silos? I think maybe through NGFA, maybe through Jeeps, we as an industry can probably put a task group together with the right consultant and do a LOPA on a silo and understand, are we in that 10 to the minus 5, which means one silo explosion resulting in a fatality every 100,000 years? Well, Cargill has 50,000 silos just by ourselves. So if you add the industry up, that means if we're worse than 10 to the minus 5, we'd be having fatalities from silo explosions you know, more than once a year. Now, there are explosions more than once a year, but they're not all fatalities and they're not all silos. So I think we could do some sort of a LOPA, come up with this analysis, and use that for our industry. So we've done this analysis, and we think with, as long as you have all these mitigation strategies in place, we think we're meeting the risk tolerance that the industry is trying to meet. And use that instead of doing an analysis on, instead of everybody doing an analysis on all their silos and spending a lot of money and a lot of hours. And I don't think there's enough consultants in America to get them all done. So I think that's one thing that we could probably work together on, if it comes to fruition.
I think another thing to point out too is the revision cycle, right, that NFPA, these standards have to go through. So it's about every 5 years, correct? So, and usually the process starts, it'll be 3 years from now, right? So once it's finalized, as Craig mentioned, probably just December, January, then we'll have about 2 years, no activity in the committee for about 2 years, and then they'll start the revision cycle, and they'll be accepting proposals for changes, right?
Public input. So that'll be a great opportunity. So another reason to read the standard and arm yourself with information is so that, because it's hard to look at the entire thing in its entirety without the book in front of you. We've tried to do our best online and, you know, paging through, you know, photos of it. But once you get it in your hands and start reading it, there might be some conflicts in it that says, this says I'm supposed to do this. It didn't say that last time. That's a major change for us. Maybe that was a mistake. Maybe it was the reference is wrong. Maybe it was a misinterpretation of what was intended. Those are all good examples of public inputs back to the committee and say, hey, on 9.4.3.3, it said I had to do X. And that isn't even standard for our industry, and I think we should change that to, you know, say something different. The committee has to look at every single public input in committee. So if you really want to help shape how the standard is coming together, and I think it'll take more than one cycle to get it actually good, read it and submit public inputs, because those matter. And in my opinion, it matters more for you to send them individually as in your companies than let's all get together as one group and submit public inputs. The committee looks at that as one public input, not 50 different companies submitting the same company. They just say, oh, that's just one. But if they get 20 of them, that's 20 public inputs. So it's better, it's more effective, I think. The more the better.
Yeah, and when the committees meet, right, so it could be a 3-4 day meeting going through all of the public inputs, because that's where there's the discussion with the committee, right, saying, okay, well, we agree, we disagree, we want to make modifications, and then it has to go through a vote for the committee, and then the following year, the committee meets again to review all of the revisions that have been made to make sure everybody's on the same page, and then after that, most of the time it goes through the NFPA has to formally approve it at with the Standards Council. So there is, as Craig's saying, there's still an opportunity for all of you to be involved in submitting comments. You know, after you've had a chance, as he said, to review it, implement it. You know, and any feedback you have for us that serve for representatives on the committee, that's helpful as well.
Yep.
So. Any other questions, comments here on the issue?
They're getting thirsty.
It's got to be. Okay, well, going once, going twice. Craig will be here if you have any specific questions for him. So with that, Craig, I appreciate it. Thank you for your presentation.
Yep, very good. Thank you for your attention.
So this concludes today's presentations. I would like to thank all of our distinguished speakers for their informative and insightful presentations and discussion today. Let's also thank our sponsors for CONVEY'24. Our partner sponsors are CCS Group, McPherson Concrete Storage Systems. Our supporting sponsors are JD High School and Company, Safety Made Simple, McCormick Construction Company, Westside Salvage. Our contributing sponsors are CoBank, M&M Specialty Services, Dagesh, and United Grain Corporation. Please join me in thanking these generous sponsors. I now invite you to